We've been talking a bit about ARCore and what it has to offer, but the truth is, my go-to solution right now is accessing its functionalities through ARFoundation. Why is that? Because ARFoundation is the wrapper Unity has created, so you write the code once and it works for both ARCore and ARKit. That is great because even though they might have some different features, they essentially do the same thing. However, I struggled more than once trying to find how a method works or how to customize things to work my way. So here's an introductive guide that aims to show you how ARFoundation is layered. I think that it is important to have a general overview in the beginning, even more than doing step-by-step tutorials, as it's still in preview mode and breaking changes still come and go, and hopefully more and more features will appear each year. Learning resources. About ARFoundation page. Make sure you read the version you work on. This page is great as it gives you not only information about getting started, but also has some short tutorials on other things you can do. The things you can learn just by reading this page include getting started, how this library works, what most managers do, raycasting, face tracking. GitHub code samples. Theory is great, however, we sometimes need to see exactly how some pieces of code are written. Don't worry, for most use cases you are going to implement, the code is already written and public. Therefore, this is the most powerful resource. Unity offers us examples for a great majority of use cases that either work out of the box or are easy to read and understand. Whenever you're in trouble, clone this repo and just give it a spin in Unity. Documentation and IntelliSense. So right now you might have already all that you need for 80% of use cases, but sometimes you really want to know if you can do something. Most of the times what we look for can be found by just reading the old boring documentation, or if you're lucky, just in the class definition. Here's an example where this helped me. I really needed to make my own plane over every AR plane. I already knew from GitHub that I can access all planes by getting the Trackables. But how do I get its properties? Just by enabling the IntelliSense, we can see it has a center and boundaries that we can get some of the information we need from. Going in the documentation, we see exactly what does it mean. However, they say boundaries are local and they are in 2 dimensions. Why is that? Well, if we go into the AR plane definition, Ctrl+click, we can see it inherits mono behavior. So AR plane is the script attached to our trackable game object. That's how we know we can take the transform's global position and rotation after we create the plane. Now that you know where to look for help and how to properly learn this, here's a small guide on what are the layers of ARFoundation and what it is built upon. Once you'll understand this, you'll mostly need the resources just for implementation details. The ARFoundation philosophy. AR session and AR session origin plus the camera. Every ARFoundation experience starts with only these 2 prefabs. AR session manages the whole AR state or the so-called session. The state of the whole system is managed and provided through the AR session class, and you can actually monitor if everything is installed, available, tracking, unsupported, and so on. AR session origin is the parent of all objects in your scene that you want to be anchored in the AR space. This space is called the session space. By default, the main camera is to be a child of this. All the trackables and other anchors will be instantiated under it. It is responsible with transforming all its children in the new tracked AR space. For instance, you can see if you simply instantiate objects outside of it, they still appear where they should be. However, if tracking is obscured, ARFoundation will recalibrate itself, but it won't affect the outside children. That's why it's important to anchor all our objects inside it. Here we will also put most of the other scripts that interact with the AR world, such as trackable managers, raycast manager, and so on. In AR, camera is special as we will give its complete control to ARFoundation. And how does it do that? Tracked pose driver. Most of the times we will want to leave the camera's transform, do whatever ARFoundation wants to do with it. Subsystems. ARFoundation is just a wrapper. You would still need to import ARCore or respectively ARKit depending on what you need. Since the 2 libraries are very similar, most of their methods are called in a similar way. These interfaces are called subsystems and are mostly accessed under the namespace of unityengine.xr.ar subsystems that you're going to use a lot. Subsystems are not implemented into ARFoundation but in different packages called subsystem providers. That's why we have to also import the ARCore XR plugin and ARKit XR plugin. Once you enable a feature like, let's say, plane detection, a specific subsystem is created to handle it globally. All this is managed through a subsystem manager. Each subsystem has a lifecycle: create, start, stop, destroy, and they are accessed through a so-called descriptor. They are mostly used to grab and track changes about some trackables offered by the underlying system, in our case ARCore and ARKit. Subsystem creation is usually the job of the SDK and hardware creators, so we don't need it more than understanding the concept. Manager scripts. For most of the things you want to do in a scene, you just have to bring a manager class in the scene. We're talking about handling most trackables, point, plane, image, face, human body, do things with the camera, or more specific stuff such as doing a raycast. Some of them, mostly the trackable ones, bring a new subsystem into our app, others won't. For most operations, we will interact with them using their public attributes, public methods, and most recommended public events. I won't go through what each script does, since managers will come and go, but remember, looking into what each of these classes has to offer usually encompasses all the information you will ever need. Trackables. The most important managers are those who inherit AR Trackable Manager class. Each Trackable Manager inherits AR Trackable Manager and has a trackable attribute that gives you access to them. Trackables are instantiated under AR Session Origin as game objects. Each type of trackable inherits AR Trackable and has its own attributes, and they mostly are in local space, as the global transform is controlled by the manager and can be found inside the game object's transform. Each trackable has its unique trackable ID and state, while we usually have access to events through its manager, so we know when each one was added, changed, or removed. In a nutshell, let's wrap this up. Subsystem providers are at the base of everything. They can be coupled or decoupled as pieces of puzzles. All this is managed by AR Session that observes what we need based on what managers we put in scene or not. Whatever we want to work with, we need a manager. Managers can be about trackables, camera, or utilitary stuff such as raycasting. Trackables each have a trackable ID. When talking about trackables, subsystems provide us with events about added, changed, and removed trackables that we can subscribe to, and managers also consequently update trackables in the scene. All the trackables are AR anchored objects and are parented to AR Session Origin. Its 000 point is where the camera will be when the camera opens up, and can be recalibrated in time if tracking is lost. Examples. Let's loosely now give a look on how these terms apply on some existing examples. Trackables. Point cloud, planes, image tracking, face tracking, and body tracking each have its own manager that inherits AR Trackable Manager. Each of these trackables is stored inside Trackable's public attribute. Each trackable is attached to a game object under AR Session. Each manager offers us events for add, changed, and removed we can subscribe to. For point clouds, we have a list of 3D positions. For planes, the center, boundaries, and extents. For images, we have position and scale. For faces, an ever-updating mesh, and for body, a hierarchy of joint positions. They're all similar to use. Conclusion. So that's about it. Things will come and go inside ARFoundation. Some changes might even break all your code. However, the underlying mechanisms will be the same, so keep that in mind, and good luck on building creative and awesome stuff with this amazing library. If I said anything wrong, I missed something, you have any feedback or question, please leave a comment and subscribe if you found it useful. See you next time.